Okay, got this big box, ordered an item through eBay. It's not a new item, it's just new to me. So let's go and take a look, see inside, see what we got. Big bunch of styrofoam. Got lots of peanuts. And this thing is heavy. What this is an Eico This is an Eico 1030 high voltage regulated power supply. This is for working on tube type equipment. It has a milliamp dial or meter. It has a DC volts which will read up to 400 volts. It supplies bias voltage for tubes, which is a minus voltage. Filament voltage, either 6.3 or 12.6 volts AC, and of course the high voltage, which will go up to 400 volts. Before we even plug it in, we're going to take it apart. Unwrap the power cord. Easier said than done. It's a little dusty inside, cobwebs and everything. Uses two 6L6s, rectifier tubes, 2 of them, and some OA2 and an OB2 voltage regulator tubes, and a small tube for controlling the voltage. Looking on the inside, looks like at some point the capacitors have been replaced, but they're probably pretty old. and we're dealing with this much voltage, up to 400 volts, I just don't trust those old capacitors. So we'll be replacing all the electrolytics and checking the resistors for values and getting rid of cobwebs. Okay, I've flipped the unit over. There's these two capacitors, these two, and these two. This one here is actually a double capacitor. That's 220 microfarads at 350 volts. This is 40 mics. These are 20 mics at 500 volts. And these are 80 mics at 350 volts. These two are actually in series because the high voltage on this is around 640 volts. So let's dig in. When we're done here, I'm going to test these and just see how good or bad they really were. That goes for all the capacitors. Okay, so I've gotten these two big caps out, and here's their replacements. I'm going ahead and disconnected the other end of that and feeding in the wire to the terminal block on that end, and on this end, and the original made a U-turn up here. So I'll make room for the second one. The positive is here. This negative joins up with that positive, and I'll need to remove the little bit of wire from there. Okay, so the hole over here is now clear. Put that cap in, make good mechanical connections. And we'll go put the negative end of 20 mic 500 volt capacitor. I have one here with some heat shrink. And just line this end up for the moment. Again, make good mechanical connection. Throw some solder on that. Solder up this end. And solder up this end. And get rid of the stray hunks of wire. This wire cutters has an extra little thing here that keeps the wires from flying everywhere. Okay, that needs a little more solder there. kind of close quarters in here. Make sure it's securely attached. Get rid of the extra wire. Doesn't always catch the strays, so that's a nice thin okay, so the next thing we have to do is connect the positive end of this capacitor here, of course, is also connected to the switch. So cut the minus end of that. And again, like I said, this one here is actually a dual capacitor. One half goes there, one half goes there. And there's a dual capacitor. So I'll clean that up. Sometimes adding a little fresh solder helps it flow better. I'm just working these around, gets them easy to take out. And then just clean up a little solder wick. Feed that through the hole of the switch. Now we need two 20 mic capacitors. Which will take place of the single dual capacitor. So rather than trying to run all the wires through the hole in the switch, take these, bond them together, clip one of the leads. See if we can fish that through. Here we go. Again, try to make a mechanical connection here. And we'll throw a little solder on that. Things like to move sometimes. And make sure everything is well attached. Get rid of extra wire. This end goes to this terminal block here. Bend or cut off the offending piece there. We'll put a little heat shrink on that. That's a little too long. Here, a little heat shrink just like that. Push that through. Make a mechanical connection. Mechanical connection just like that. Make sure we're well connected, that we didn't loosen up the old connection. Turn this so I can see what I'm doing. This other capacitor goes here. Add a little fresh. Got a little dripper. We have this old piece loose, and there it comes out. And there's the excess solder blob that on the chassis. And we'll just put that right in there like that. Make it nice and tidy. Make a good mechanical connection. Throw a little solder on there. Make sure everything's still tight. Check the other wire, make sure we didn't loosen that up. And remove that piece of solder. So we have two more to go. Again, I'm going to turn it so I can see what I'm doing. The negative end goes here for a 47 mic capacitor. So here's a 47 mic capacitor. I'll just give that a little snip there. And while we have that up, I'm going to replace that because that's down in behind it there. So that's a 20 mic at 500 volts. And the negative end goes here. So both negative ends are up there. See if we can loosen that up. Well, that came out real easy. Just push that excess solder down. Remove from the board the other little scraps. And we might have to remove a little solder so we have a hole to put our capacitor through. The solder I use is the NTE. It comes on a 25-foot spool, which will give a nice mechanical connection. And throw a little solder on there. And make sure everybody's tight. .500-volt cap and this cap both come to the same point here. There's a lot of stuff on that. So I'm going to clip this back a bit. I'm going to clip this back a bit. Rather than trying to clean that out, I'll hook around the resistor here. So you can solder them both right there. And we'll check both of these, make sure they're attached and haven't come loose. A little straight piece of wire there. This wire here. Mechanical connection. That's nice and tight. Get rid of excess wire. And it looks like the capacitors are in. That's what it looks like with the new capacitors. And we're pretty much ready to go and test. And we have 102 volts. The rectifier tube is out, so we won't have any voltage on the main filters. I'll put the main filter in, the main rectifier, I should say. And we'll put power to it again. Again, it's only 25 volts, so nothing should be doing anything. Come up to full voltage. Got 600 volts across the main B+. We got 329, 384, and here we have 269 and 270. So at this point it looks pretty good. Okay, let's power it up and see what we got. I can pick up the minus from the front panel, or the ground, neutral, whatever you want to call it. So going into the 082 should be about 255 volts. And we have 257. That's close enough. We can check the OB2, which should be about 105 volts. And that's 107. That's close enough. Let's flip it over and see where B plus is. And it's coming up, coming up. And we'll adjust it the whole way up. And almost on the money. Just a little tweak. And 399 volts. That's close enough. We'll take a look at our bias voltage. Switch over to bias. And 189, we'll call it 190 volts. That's good enough for any bias I'll ever come across. So it looks like that is complete. Just need to power it off. The chassis cleaned up real nice, cleaned off the tubes. Here's the two regulator tubes. OB2, OA2. This is the driver for the outputs. The negative supply rectifier and the main B plus rectifier. So I said I'd check those caps for you, so let's do that right now. I have two different meters I can use. This is a cap and ESR meter. We'll clip on one end, clip on the other end, and test. It says 89 mics, ESR of 21. And that is a capacitor that is rated, should be 80 microfarads. So that may actually still be good, but gosh, I just don't trust capacitors that can be 50 years old. 90 microfarads. Okay, this is the two section. This is a 20 and 20. $24, $23. Amazing. This is a 40 mic. Uh-oh, my battery's low. See if we can get another test. 42 on a 40 mic. And the biggies. we'll go over here and use this tester. Should be a 20 microfarad. And it reads 24. And another 20 microfarad. And that one reads 24. So actually the old caps were good, but like I said, when they're that old, I just don't trust them. So there it is, the Eico 1030 high voltage power supply. All caps replaced and working great. Thanks for watching.